right, so we're going to take a look at another problem, a type of problem or a concept that you might encounter on test 2. And don't want you to miss a problem like this. So let's take a peek. Find the area under the standard normal curve to the left of z equals -3. Use the empirical rule. Okay, let's draw our normal curve. Okay. So here's our mean. Usually it's denoted by x bar or mu. And then we have data that goes above the mean. These are your z-scores or your standard deviations. All right, so most data, if it is considered normal, will fall on this curve. So you could be below average by 1 jump or 2 jumps or 3 jumps. And remember, this is just what we consider to be average, right in the center. Okay, so we know that this piece is 50%, and for this half is 50%. Now the empirical rule helps us break that down a little further. So this thing tells us that if you are within 1 standard deviation of the mean, you have 68% of your data that's been captured. So if we go up 1 or down 1 away from the average, 34% of data happens to fall in there. Okay, so 34 and 34 is 68%. That's pretty normal. That's where most of us fall. Pretty boring, pretty average in between, right? -1 and 1. Nothing really exciting. Okay, the empirical rule tells us that if you get data that's out 2 deviations, that's about 90, that'll capture about 95% of us. Okay, so that means we're going to come out to here and out to here. So if we already have 68% sucked up and we need 95%, that means we got to throw 13.5% here and 13.5% here. Because if you take 13.5 plus 13.5 plus 68, you'll get 95%. Okay, now this is asking about the left of z equals -3. So the left means we're going to be going that way. So we need to continue going out. Let's keep using the empirical rule. So standard deviation of 3 deviations, here and here, we know that that captures about 99.7% of data. That means we got to come out a little further here. All right, so we're going to put 2.35% here and 2.35% there, right? Because if from here to here is 95%, right? We want to get to 99.7. We want to add in another 2.35 on this side and another 2.35 on this side. Now this whole thing adds up to 100%. So that means there is a little something in the tails. So the tails have, these are very unusual data falls right here. So that's 0.15%. And this over here is 0.15%. So the question is asking us, what's the area under the curve to the left of z equals -3? So that's this little piece here, this little chunklet. Okay, now the chunklet is 0.15%, but in decimal form, if you divide that by 100, the area is actually 0.0015. So be careful. If they don't want it in percent, right? They don't want this. They're going to want you possibly to give it in decimal form. So you might need to convert. So just a heads up if you get something problem like this or a concept like this. Hopefully this is helpful. I'll see you in the next video.